so that's what we're going to just review and do today. We should get through the review quickly today then. All right, so just remind, give me a definition of what differentiation is.
Differentiation, a definition.
Yeah, what is differentiation? Or what comes to your mind when you hear the word differentiation?
What comes to my mind when I hear gradient?
Gradient, very good, beautiful. Gradient, that's the right term. All right, so when we differentiate, differentiation is the process of finding the derivative of a function at a particular point.
Okay.
The differentiation is the process of finding the gradient or the derivative of a function at a particular point. All right, that's differentiation. And so generally, usually we're going to use differentiation to find the gradients of a curve. All right, so let's just put some axis right here. Let's say we have the x and y axis like this. So we have the x-axis and the y-axis. We can have some curve that's looking like this, right? And
Right.
at any point on the curve, at any point, the gradient at this point is going to be different from the gradient at this point, and it is different from the gradient at this point, right?
Right.
And so we needed some process to be able to can find the gradient at each point, and so hence they came up with the process known as differentiating. All right, and so the definition of differentiation in terms of mathematics, how we would write it is that differentiation, which gives us derivative, and so if this function is f of x, let's write it down. If this function is f of x, then the derivative of the function f prime of x, it is given by f prime of x is equal to the limit. This is definition of a derivative. It's equal to the limit as h tends to 0, the limit as h tends to 0 of f of x plus h minus f of x divided by h. F of x plus h minus f of x divided by h.
I remember this.
Yes, this is known as the definition of a derivative. And do you know how they came up with this formula?
No.
All right. So let's do a quick run through of how they came up with this formula, this definition of a derivative. Now consider this curve, right?
Right.
Consider we have this curve. We already have it right there. Now let's say you wanted to find the gradient at this point. How would you find the gradient of this point without knowing differentiation? What would you do?
You could draw I remember the lines from
Yes,
the curve to
very good. So you could draw what is known as a tangent. You're going to draw a tangent line at this point right here. So we're going to draw some tangent line, right? And it only touches this point on the curve. Okay, my line is off right there. We're just going to draw some line. We're going to draw the tangent line that only touches the curve at that point. My tangent is off. This should be a straight line. I'm sorry. Let's try to fix that. My curve is off. Oh boy. All right, my curve is off. But just imagine that this line is straight, all right?
Yes.
Let's just picture it as a straight line. So this is the tangent at this point, right? That's how we would find the gradient of this curve, right? Now this is the tangent, right? And
Right.
the tangent, the gradient of the tangent is equal to the gradient of this curve at that point. Now what they're saying is take away this tangent. Let's say we weren't even able to use the tangent, right? Let's say we're not able to use the tangent, right? Let's say we don't know about point of tangency yet. Now this is what happened now. what they're saying is that a point that is very close to this point, right?
Right.
Let's say there is a point that is very close to this point. What they're saying is that if there is some point like this that is very close to this right here. So let's say that red point is the point A when x equal A, right? So this is our x-axis, and that's the point x equal A. Then right here we have our y-axis. Then the corresponding y value, and I don't even need to say A. Let's just use x, right? It's x-axis, and we're just gonna call the value x. Just gonna call it x. All right. So let's say we know this is some point x. And so the corresponding y value for this is going to be f of x. You agree?
Yes.
So whatever that x value is, we just get f of that x value. Now right here, now this point that is very, 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 very close. So if x is 3, this point could be 3.000000001, right? It's very close to it. All right, so let's magnify this graph now. So we're going to magnify it. So imagine that we magnified it now. So we'll magnify it, and now the graph is going to look something like this. So throw away that part right there. So only focusing on from the turning point upwards. And so we magnified it. The point that we was looking at was right here and right here. So you see how far this point moved here? Because we're magnifying it now. We're zooming in on what is happening. So this is the point x. This is the point x. And this is some point, let's call it x plus h. So the distance between here and here is h. And so we can then say that this point would be x plus h. Agreed?
Yes, sir.
So this would be x plus h. And so therefore now the gradient of the curve is going to be approximately equal to, so the gradient of the curve would be approximately equal to the gradient of the line. Remember, it's not equal to it, but it's approximately equal to it. So we're calling the gradient f prime of x. So f prime of x would then be approximately equal to, it's going to approximately equal to, how do we find gradient of a line? y2 minus y1 over x2 minus x1. Agreed?
Yes, sir.
And so y2 would be this point right here. y2 is going to be, if this is x plus h, then y2 is f of x plus h. Agreed?
Yes.
So y2 will become f of x plus h. Then we have minus f of x all over x plus h. Now this is x2 minus x1. x2 minus x1. So we have x plus h minus x. But then x minus x, that gone, right?
Yeah.
So then the x, this plus x here, take with the minus x. And so what we're left back with is just h, right?
Yes.
And so the gradient of the curve is approximately equal to f of x plus h minus f of x over h. But no, this is approximately, it's not going to be equal to it, right? But now as h goes to 0, look what happened. As h goes to 0, what's going to happen? As h goes to 0, think about it. As h goes to 0, then we're no longer focusing on this line, but then what the line becomes is the tangent line. Can we see that?
Yes.
Because as h goes to 0, then it becomes a tangent line. And then as h goes to 0, this is what happens. We take the limit of it. And so the limit as h goes to 0 is f of x plus h minus f of x over h. And then that would give us the exact gradient of the function. And so we call that the definition of derivative of a function at a point. All right?
Okay.
And this is how they get the formula. So that's how they came up with the definition of a derivative. All right. And so now, since we're discussing the general rule, talk to me now. If y is equal to ax to the n, how do we differentiate this function?
If y is equal to ax to the power of n, to differentiate dy by
Yes,
dx
very good. dy by dx, or f prime of x.
is
Sure.
equal to n
Yes,
multiply by x raised to the power of n minus 1.
very good. So that's how we differentiate. So dy by dx is then equal to, we bring down the power n, then we subtract 1 from the power. So we bring down the power n in front of this term right here to get n times a, then we subtract 1 from the power. So let me give you an example. Let's say for example, y equals to, y is equal to 3x cubed. Y equal to 3x cubed. That's what is dy by dx.
Dy by dx is 9x squared.
Very good. Dy by dx is equal to 9x squared. 9x squared. Very good. So that's the general rule of differentiation. So in order to differentiate a function, all we do is carry down the power and subtract 1 from the power. But this is just the general rule. This is the general rule of differentiation. The general rule. All right? So this takes us for a lifetime. Now, of course, we're not always going to be given this one simple function. There are many different types of function we'll be given. All right? Now, so the first one that we're going to next review is how to differentiate sums and differences. Sums and differences. What sums and differences mean is that, let's say you're given some function f of x, and it's a polynomial function. F of x is equal to ax, it's equal to a1 x to the n plus a2 x to the n minus 1, and so on, x to the n minus 1, and so on. What we do to differentiate this function is we differentiate each term in the polynomial function. So what we then say is that the gradient f prime of x would be equal to differentiating each term of this right here. So it would become n times a1 x to the n minus 1 plus, bring down this power, we get n minus 1
Minus 1
times
to
a2
x to the n minus 2.
very good, x to the n minus 2. Nice. All right, so let me give you an example that we're going to do together. So example, let's say f of x is equal to, let's say it is 3x cubed minus x squared plus x minus 1. So what would be the derivative, f prime of x?
F prime of x is equal to 9x squared
9x squared, very good.
minus 2x plus 1
9x squared minus 2x
plus 1.
plus 1, very good. Very good, and that's how we differentiate sums and differences. Nice. So that's the general rule for differentiating sums and differences. The next one to review is how to differentiate product and quotients. How to differentiate product and quotients. All right. So to differentiate product and quotients, generally for products, this is what they do. So P right here stands for product. Generally, to differentiate a function that's a product, so let's say f of x is equal to, let's say u times v. I don't like to say u times v, but this is the general thing that they tell us. If f of x is equal to u times v, then f prime of x is u dv plus v du. Then the derivative f prime of x is equal to u dv plus v du. Or some people spin it around and say v du plus u dv. v du plus u dv. v du plus u dv. So then that is f prime of x. Alright? You remember this one?
Yes, sir.
Alright, so that's the product rule. So let me give you an example now. Let's say y is equal to x plus 6 times x plus 6 times 4x minus 1. How do we differentiate this now?
You differentiate the second bracket first.
Alright, so dy by dx is, so what I usually tell my students is that v du plus u dv, so this is your v, right? So just write back v first. This is your v, right?
Mm-hmm.
You identify your u and you identify your v. So you write down your v first. So it is 4x minus 1. So that's your v times du. du, the differential of x plus 6 is what?
1.
1, so you just write 1 times 1 plus, write down your u first,
X plus
x plus 6
times 4.
times 4, very good, times 4. And so what this works out to be then is, we can simplify it if we want. We get 4x minus 1 plus x plus 6 times 4, that becomes 4x plus 24.
Yeah.
Okay. So if we want, we can go further to add it. And so we get 4x plus 4x is 8x. And then minus 1 plus 24 is 23. And so that is dy by dx. So this is dy by dx. Alright, dy by dx is 8x plus 23. And so that's when we have a product. Now let's look at a quotient. Quotient rule. This is quotient rule now. So for quotient rule, I use a funny formula to remember it. I hope it's funny for you too. This is quotient. For a quotient, where f of x is equal to, I call it t over b. I'm going to explain why I said t over b now. F of x is equal to t over b, then f prime of x is equal to b, it's equal to b times dt minus t times the differential of b, which is db over b squared. Over b squared. I'm going to tell you why I use this formula now. Why I use t and b instead of u and v. What I tell myself is, I always start with the bottom and I end with the bottom square. And from that day, it never come out of my mind from way back in high school. Alright? So that is what I use to remember it. You start with the bottom and you end with the bottom square. So it's equal to, you start with the bottom times the differential of the top minus the top times the differential of the bottom over the bottom square. And so from that day, I never forget it. All right, that sounds easy to remember, right?
Yes, sir. But
All right,
I remember
I know, I
the
know.
other one.
Oh, U over V, right?
V U prime minus U V prime over V squared,
I
because
know, yeah.
my ad maths teacher taught us even when we were doing the products to use VU plus UV instead of the other way around, so that when we're doing quotient we just use by the same thing and you divide it by the V squared.
Yes, yes, that is very good. And I like that teacher. At least he didn't make you get confused because a lot of teachers teach it with the product rule that they're saying VDU plus UDV, but then
Yeah.
it is not VDU minus UDV, so it gets confusing. So I like that he's consistent. But what I do is I tell myself top and bottom, all right? And I remember top and bottom a lot better. So, but it's the same thing. So let's use an example now. So let's say f of x. Let's say f of x is equal to, let's say f of x is equal to x minus x squared over 2x plus 1. X minus x squared over 2x plus 1. So then what is f prime of x?
F prime of x is equal to 2x plus 1
Very good. Start with the bottom.
times negative 2x
Times negative 2x.
plus 1
Negative 2x plus 1. Very good. Times the differential of the top minus
minus x minus x squared
x minus x squared. Very good.
times 2
Times 2, which is the differential of the bottom, which is 2, divided by,
x plus 1
very
squared.
good, very good, divided by the bottom square, 2x plus 1 all square. Nice. So now that gives us f prime of x. So we can go further to simplify it if we want by saying then that f prime of x is equal to, always simplify it, so 2x times minus 2x, that gives
Negative
us
4
negative
squared
4x squared. Nice.
plus
Then what we have is 2x times 1. We have
then
2x times 1 and
and
1 times minus 2x. Those gone, right?
yeah.
So that part gone. So
So
we
you
can just,
1 times 1.
so we just left back with the 1 times 1, which is plus 1.
1.
Nice. So we have plus 1. Then we have minus 2 times x is
2x
2x. So we have minus 2x. Then I can put a plus because the minus and the minus here becomes
plus
plus. So
positive
get plus 2x squared divided by 2x plus 1 all square. 2x plus 1 all square. So we can go further and simplify it even some more. And so it would just becomes minus 4x plus 2x squared. That just give us minus 2x squared. So let's just put it in one. Minus 2x squared. Minus 2x squared minus 2x plus 1. So it just works out to be minus 2x squared minus 2x plus 1. Very good. Nice. So that's quotient rule. And the next thing that we're going to look at after quotient rule is chain rule. Chain rule. This is the most powerful rule, right? Chain rule is the most powerful rule because this is the one we're going to be applying most of the time. Chain rule. And what chain rule states is that if we have y is equal to a function of x, if y is equal to a function of x raised to the n, y is equal to a function of x raised to the n, then what it tells us then is that dy by dx, instead of writing dy by dx, what you're going to see they use in unit 2 is y prime. Y prime means the first derivative of y. Alright? So you're going to be seeing this a lot in unit 2. They don't say dy by dx so much anymore. So y prime is equal to, we bring down the power n, then we subtract 1 from the power to get f of x raised to the n minus 1. But then we times it by the differential which is inside the bracket, and the differential of f of x is f prime of x.
F prime of x.
F prime of x. And then that gives us the result for y prime. And this is known as chain rule. Alright?
Yes, sir.
Sometimes you might say they write composite rule, but it's the same thing. Chain rule, composite rule. Alright. So now let's look at an example. So let's say y is equal to 3x squared minus 1 raised to the 5th power. How would we differentiate that?
Okay.
The dy by dx, or y prime
is equal to 5 3x squared minus 1
3x squared minus 1, very good,
raised to the power of 4
raised to the power of 4
multiplied by 6x
multiplied by 6x. Nice, very good. All right, and so that is y prime, and so we can go further to simplify it to get that 5 times 6x is 30x. 30x times 3x squared minus 1 to the 4th power. Nice. So that is chain rule. All right. Now that we've completed chain rule, the next thing that we're going to be looking at or reviewing is how to differentiate trig functions. All right, so trigonometric functions.
Sigh.
Why you say sigh?
Because I can never remember how to differentiate sine and cos.
Alright, don't worry about it. It's very easy.
Equal to negative sine, or sine is equal to negative cos. I don't remember.
So if y is equal to sine x, then the differential of sine x is cosine x. So y equals sine x, then the differential of sine x, which is y prime, is cosine x. So when you differentiate sine, you get cos. Easy to remember. When you differentiate sine, you get cos. Alright, and let's not just write x, let's write f of x. If we have y is equal to a function, sine of a function of x, then y prime is going to be equal to cosine a function of x times f prime of x. Times f prime of x. So example, let's say y is equal to sine x squared. Y is equal to sine x squared. And what is dy by dx?
Dy by dx is equal to cos x squared
Y prime is equal to cos x squared
times 2x.
Times 2x. Very good. Cos x squared times 2x. Nice. And so this simplifies to just be 2x cos x squared. 2x cos x squared. And so that is y prime. Nice. All right. Now the next one to look at is differentiating cosine. So if y is equal to the cosine, if y is equal to the cosine a function of x, then dy by dx is equal to minus sine, minus. So when you differentiate sine, you get cos. When you differentiate cos, you get minus sine. I always tell myself that to remember it. The differential of sine is cos, but to differentiate cos, you get minus sine. So you won't get it mixed up ever again, alright?
Okay.
Alright. You won't ever get it mixed up again. So y is equal to cosine f of x. And so y prime is minus sine f of x times f prime of x. So let's look at an example. Let's say y is equal to, x cosine 3x. If y is equal to x cosine 3x, what is dy by dx?
dy by dx is equal to negative
Negative,
x
negative x
sine 3x
sine 3x.
times 3,
Very good.
which can be simplified to
Plus what?
oh plus
Plus, this is quotient, this is product rule. So look, x plus 3x, that's why I give you this one. Yes, to see if you're paying attention. So this is product rule. So x cos 3x, you use product rule. This is your u and this is your v, or this is your v and this is your u. Alright? So
okay,
then now we get plus
plus 1 times cos 3x.
very good. 1 times cos 3x. So yes, that's why I gave you this one to test. Not only to differentiate trigs, but just to wake up our memory with product rule. That remember, anytime they give in questions, they're going to be mixing it up. And that's the whole reason for us going back over these stuff. Because in Unit 2, they're assuming that you remember everything from Unit 1.
Okay.
And so Unit 2, we're going to be doing different stuff in differentiation, but you're still going to be seeing these same principles. So it's good to review them, all right?
Yes, sir.
All right, so finally it works out to be y prime is equal to minus 3x
X sine x
sine 3x plus cos 3x.
yes.
Nice. All right. So now that we have that covered now let's go ahead and differentiate tan. Differentiating tan. How do we differentiate tan?
Differentiate tan and you get cotan.
When you differentiate tan, you get cotan?
Yes.
You sure about that?
Yes.
All right, so when you differentiate tan, let's verify that now. All right, when you differentiate tan, I think we get sec squared. So let's verify it. Now y equal tan x is telling us that y is equal to sine x over cos x. Do you agree with that?
Yes.
So y is equal to sine x over cosine x. And so now we can use quotient rule to differentiate this, right?
Yes.
All right, so let's use quotient rule. So dy by dx is equal to, we start with the bottom, which is cos x, times the differential of the top. When we differentiate sine, we get cos x, minus the top, which is sine x, times the differential of the bottom. When we differentiate cos, we get what? Minus sine, right?
Sine.
Very good. Over the bottom square. and cos x all square. So we get cos square x. Now right here, the minus and the minus right here make it become plus, right?
Yes.
We multiply two negatives, we get plus. And so what we're getting is cos times cos x become cos square x. Cos square x. And then sine times sine x becomes what?
Plus sine square x.
Plus sine square x. Now what is sine square plus cos square?
1.
Sine square plus cos square is 1. And so what we're getting is 1 over cos square x. We're getting 1 over cos square x. So that's the differential of tan x, 1 over cos square x. But now look at this. 1 over cos square x, I can write it as 1 over cos x times 1 over cos x. 1 over cos x times 1 over cos x. Do you agree with that?
Yes.
But then what is 1 over cos x?
1 over cos x is sec.
Sec x. So 1 over cos x is sec x. And then we're multiplying it by sec x. So sec x times sec x is?
Sec x squared.
Sec square x or sec x all square. So
Yes.
we get sec square x. And so then if y is equal to tan x, then dy by dx or y prime is equal to sec square x. Sec square x. Oftentimes you're not going to get just x. Oftentimes it's going to be a function of x. And so then it would be y prime is sec square function of x times f prime of x. Let's look at an example. Let's say, for example, I tell you y is equal to the tan of cosine x square. Y is equal to the tan of cosine x square. What would be dy by dx?
Y is equal to tan times the cosine of x squared. So this is a product rule.
Product rule, you sure?
No.
Think of all of this as, so what, when they say y is equal to the tan of cos x squared, think of all of this as big X. So if y is equal to the tan of big X, then when you differentiate it, you would get sec squared big X, but then you need to multiply by the differential of big X, right?
Okay.
Alright, so to differentiate this now, what you would do is say, alright, y prime is equal to, when we differentiate tan, we get sec squared, but then it's going to be sec squared, whatever is in bracket. In this case, in bracket is not just x, in bracket is cos x squared. But using chain rule now, we're not done yet. We have to then multiply it by the differential inside the bracket. So what's the differential of cos x squared?
The differential of cos x squared is negative sine x squared.
Negative sine x squared. But then we're not done yet. After we multiply it by negative sine x squared, we have to times it by 2x.
2x.
Very good. So this one is lengthy. So you see what them love? Do a question where you have to do whole heap of things, right?
Yes.
That's what they love to do. And so what we get now is that y prime is equal to 2x minus 2x sine square x times sec square cos x square. Cos x square. And so that's the derivative of this tan function. Alright? That's it. Alright. So now that we finished looking at chain rule, quotient rule, product rule, and all of those stuff. The next thing that we're going to look at is be looking at gradient. All right, we're going to be looking at gradients. Gradients. So looking at gradient now, and remember when we did equations of line, when we get a line like this, what did we say the gradient is?
The gradient of the line is y2 minus y1 over x2 minus x1,
Very
or
good.
y by
Right?
d.
So when we have 2 points on the line, we say that the gradient is y2 minus y1 over x2 minus x1. And if the gradient of a slant like this way, we say that the gradient is positive. Right?
Right?
Whenever the line slants that way, the gradient is positive. Whenever we have a horizontal line, what's the gradient?
No, 0.
The gradient is 0, so we say that the gradient is equal to 0. All right? And
Right.
so anytime we have now a line going in this direction, we say that the gradient is
Negative.
negative. Very good. Now, let me give you a brain teaser. What happens if I give you a vertical line? What happens to the gradient?
The gradient is infinity.
Infinity, or the word that we use from
Or
CSEC is
no,
undefined.
undefined.
Very good. So the gradient is undefined when we get a vertical line. All right. So now, likewise, when we're given curves now, when we're given curves and we have to differentiate to find the gradient at a point, in differentiation, whenever dy by dx at a point, whenever dy by dx is greater than 0, we say that the gradient is positive. So at a point, when dy by dx is greater than 0, we say that the gradient is positive. So the gradient is positive. So I'm writing M for gradient. So the gradient is positive. Now, whenever dy by dx is equal to 0 at a point, what we say is that we have a stationary point. Whenever dy by dx is equal to 0, we say we have a stationary point. Whenever dy by dx is equal to 0, we have a stationary point. So we call it stat point, stationary point. Whenever dy by dx is less than 0, we say that the gradient is negative. Dy by dx is less than 0, then the gradient is negative. Now, when dy by dx is equal to infinity, we say that the gradient is undefined. This is when dy by dx is equal to infinity. All right. Yes, sir. Wi-Fi chipped out, so let's just give it a few. All right. Ayana, can you hear me?
Yes, I can hear you. My
Oh,
apologies.
Wi-Fi chipped out?
The light dropped.
Okay, I understand. I understand. All right, no worries. All right, so this is what we were saying though. We said that at any point on the curve when dy by dx is greater than 0, then the gradient is positive. When dy by dx equals 0, what we get is the stationary point. When dy by dx is less than 0, we have where the gradient is negative. Whenever dy by dx is equal to infinity, we say that it is undefined. All right, so let's now look at a typical question they'd ask you. So a typical question is, maybe they'd say, given y is equal to x cubed minus 3x squared plus 2, it might not necessarily be an appropriate curve, but I'm making this example off the top of my head. So let's say they say y is equal to x cubed minus 3x squared plus 2. They may ask you something like, find the gradient when x equal 1. That's one part of the question. Then they might say, determine the range of x, for which the gradient is, put I when the gradient is positive. The second one is when the gradient is
Negative.
negative. And then the third one they'd ask you is when the gradient is stationary, or when the gradient is 0. When the gradient is 0. Then they might say, hence, state the coordinates of the stationary points.
Okay.
So we're going to do this question together. All right?
Okay.
Let's have a look at this together. So it says, find the gradient when x equal 1, then determine the range of x for which the gradient is positive, when it is negative, when it is 0, then hence state the coordinates of the stationary points. All right, so for the first part, to find the gradient when x equal 1, we need to differentiate this, right?
Yes.
So tell me what we get. So y prime
So y prime equal
equal,
3x squared
very good, 3x squared
minus 6x.
minus 6x. So we're going to find the gradient when x equal 1 now.
When x equal to 1, you substitute the values of x with 1.
Very good. So let's just write that down. So when x equal 1, what we're getting is the gradient y prime. So I'm going to write gradient, which means m. The gradient m, which is equal to y prime of 1. This is how they write it. Y prime of 1, or f prime of 1, it's equal to 3 times 1 square, 3 times 1 square, minus 6 times 1, which is equal to, what's that equal to?
Which is equal to 3 minus 6, which is negative 3.
Negative 3. Very good. So automatically we know that when x equal 1, the gradient is negative. So when x equal 1, it should fall in the negative range, right?
Yes.
All right, so that's the first part out of the way. We'll find the gradient. Now the next part that we can do is says that it determine the range of values for x when the gradient is positive. So how are we going to do that?
When the gradient is positive, we would it be the second differentiate?
No, so when the gradient is positive, this is what we know. dy by dx is greater than 0. So all we're going to do is solve the equation for when dy by dx is greater than 0. All right?
Yes.
So to determine the range when it is positive, we're going to be solving 3x squared minus 6x greater than 0. So we're solving 3x squared minus 6x greater than 0. All right? And so what we can then do to solve this equation is we can divide through by 3 to get x squared minus 2x is greater than 0. And so what we're getting is x times x minus 2 is greater than 0. So as you said, factor out x. Very good. So x times x minus 2 is greater than 0. So what's the solution?
X is greater than 2.
X is greater than 2 is the only solution?
Or x is greater than 0.
Alright. So x is greater than 0. Let's sketch it. So whenever you get to this point, sketch it. What do I mean by sketch it? Sketch the quadratic. So I'm going to sketch a quadratic. Right? I'm going to sketch a quadratic. And it has roots. It has the roots x being 0 and x being 2. Agreed?
Yes.
X being 0 and x being 2. Now look at this. When is this curve greater than 0? The curve is greater than 0 when it's above the x-axis, right?
Yes.
And so these are the parts of the curve when it is greater than 0. Agreed?
Yes.
And so the curve is greater than 0 when the curve is above the x-axis when x is less than 0, but also when x is greater than 2. See that?
Okay.
And so that's the solution when x is less than 0, but when x is also greater than 2. So for example, let's try it. We said that the gradient is greater than 0 when x is less than 0. So give me a negative number.
Negative 1.
Negative 1. 3 times negative 1 square is what?
3 times 1. 3.
3 times 1, which is 3. Minus 6 times negative 1 is what?
Positive 6.
Positive 6. 3 plus 6 is 9. And so when x is negative 1, we see that the gradient is positive, which is right. All right? And then try a value bigger than 2. When x is 3, we get 3 times 3 squared is 27 minus 6 times 3, which is 18. 27 minus 18 is 9, which is greater than 0, right?
Yes.
And so whenever x is less than 0 or x is greater than 2, then the gradient is positive.
Oh, positive.
So this is the solution for I. Easy. So always when you reach this part, when you reach the inequality part, sketch the graph. You can never go wrong by sketching the graph.
Yes,
so let's look at part 2 now. Whenever the gradient is negative. So the gradient is negative when what happens?
The gradient is negative when dy by dx is less than 0.
The gradient is negative when dy by dx is less than 0. Very good. So this is when the gradient is negative. So we're going to solve. So let me go back to here. So we're going to solve pretty much, we're going to solve the same equation, but only this time we're solving when it's less than 0, right?
Yes.
We're going to solve the same equation, but this time we're just solving it when it's less than 0. So we're solving x times x minus 2, and we're solving that to be less than 0. Now, this is less than 0. What that means then is, if it is less than 0, sketch the graph and see what happens. So this is 1 root 0 and this is root 2. Now, when the function is less than 0, that means we're below the x-axis. The only time we're below the x-axis is inside here, so don't it?
Yeah.
All right, and so that gives us our solution. So it is inside here, so mean that x must be bigger than 0, but x must be smaller than 2. And this is the range of values for x when the function is negative. So let's go back to here. Look at this. It says determine the range of value for x when it is negative. Look at this. When x was 1, don't it get a negative gradient?
Yes.
Yep. And now negative 1 falls inside the range 0 and 2. So that gives us part 2. Now, part 3 now. Part 3 says find when gradient is equal to 0. The gradient equal to 0 meaning we solve dy by dx equal to 0. So if we're solving dy by dx equal to 0, then we're pretty much solving this equation again, x times x minus 2 equal to 0.
Equal to 0.
And so what are the solutions?
When it's equal to 0, the solutions are 0 and 2.
Very good. So x equals 0 and x equals 2. Those are the solutions. X equals 0 and x equals 2. Alright?
Yes.
Easy question. So the next part says, hence state the coordinates of the stationary points. What happened at stationary point?
Stationary point, the gradient is 0.
The gradient is 0. Very good. At stationary point, the gradient is 0. And so at a stationary point, the gradient is 0. And so this part was solved already when the gradient is 0. So the only thing we need is to find the y coordinates for them, right?
Yes.
We just need to find the y coordinates. And so now, what we need to do now is plug 0 into y. So 0 cubed minus 3 times 0 plus 2 is 2.
Is 2.
So we get 0, 2 is a stationary point. So we're going to tell them 0, 2 is a stationary point. They will plug what x equals 2 into y. So 2 cubed minus 3 times 2 squared plus 2, that looks like negative 2. That's negative 2, right?
8 minus 12 plus 2, negative 2.
Yep, that's negative 2. So that is negative 2. And so what we're getting then is that x equals 2 and y equal to negative 2. So these are the stationary points. So those are stationary points. So some people like to write it as a stat point. They know what you're talking about when you say stat point. Those are the stationary points. All right, one final thing before we close out today is determining the nature of stationary points. Now, if I were to give you a curve, when we did quadratics, quadratic either frown or it smile, right?
Right.
And so we said that this right here was known as the maximum point, right? This was known as the maximum point, and right here was known as the minimum point. However, for different types of curve, it might look something like this, where this is the maximum and this is the minimum. Or it might look something like this, where this is the minimum, then this is the maximum. Or the curve might look something like this, where it has no minimum or maximum point, and what they call it is a point of inflection. All right, so how do we now determine all of these things? This is where the second derivative comes in, and the second derivative helps us to determine the nature of stationary points. And so whenever we have a stationary point and we find the second derivative at that point, so whenever d2y by dx squared, this is the second derivative, whenever it is greater than 0, we have a minimum point. Minimum point. So whenever the second derivative is greater than 0, we have a minimum point.
Point.
Now, whenever d2y by dx squared is less than 0, we have a maximum point. Whenever d2y by dx squared is less than 0, then we have a maximum point. Now, whenever the second derivative is equal to 0, I'm going to write y prime prime. This means second derivative of y. Whenever it's equal to 0, this is known as the point of inflection. That's the point of inflection. All right? And that's all we need to know about nature of roots from Unit 1. Of course, we're going to get a bit more into second derivatives in Unit 2, where you're going to learn a little bit more about second derivatives. You're going to learn about concavity and stuff like that, but we just need to remember the basics first, right?
Yes.
So let's just remember the basics before we jump the gun. So let's go back to here. What if I had asked you to determine the nature of these stationary points? To determine the nature of these two stationary points, we would just need to determine which one is a maximum, which one is a minimum, or if there is a point of inflection, right?
Yes, sir.
So let's go ahead and determine the nature of these stationary points. So from here, if y prime is 3x squared minus 6x, what would be the second derivative?
The second derivative would be 6x minus 6.
The second derivative would be 6x minus 6. Very good. 6x minus 6. All right, so the second derivative is 6x minus 6. Since the second derivative is 6x minus 6, we can determine the nature of each right here. Right, so let's look at, let me make another line right here. So let's evaluate the second derivative when x is 2. When x is 0, rather. So when x is 0, so when x equals 0, when x equals 0, the second derivative, y prime prime, is equal to, we get 6x minus 6. So it is 6 times x, which is 0, minus 6, which is what?
Minus 6.
Negative 6, which is less than 0. When the second derivative is less than 0, what does that mean?
When the second derivative is less than 0, that means the point is a maximum point.
Maximum point. Very good. Answer 0, 2 is a maximum point. So I'm just going to write max point. So 0, 2 is a max point. And so next now we need to check when x is 2. So when x is equal to 2, we put a colon. The second derivative is such that the second derivative is equal to 6 times 2 minus 6. 6 times 2 minus 6, which is greater than 0, which is 6, which is greater than 0. And so this is a what?
That is a minimum point.
Minimum point. Minimum point. Alright, this is a minimum point. Very good. Alright, so before we go now, alright, we're done pretty much. Only thing I want us to do now is to sketch this curve. Why I want us to sketch this curve? Because we know the maximum point, we know the minimum point, we know the y-intercept. So we know so much things about the curve, we can sketch it, right?
Yes.
They love to ask us to sketch, so let's get in the habit of sketching. So we're going to sketch now y equal to x cubed minus 3x plus 2. X cubed minus 3x plus 2. This is how I like to sketch it. The first thing I like to do is think which one comes first. So the maximum point comes first, then the minimum point comes second. So how I sketch it then is maximum point comes first, minimum point comes second. So I start with that, right?
Right.
Then the next thing to do is put in our axis. So label our axis now. So I know that we need the y and the x, but let's just label the point before we label the axis. The point is supposed to be 0, 2. So 0, 2 is where it cut the y-axis. So I can draw the y-axis on this right here. Agreed?
Right.
Because that is 0, 2, which is the maximum point. Now the minimum point is 2, negative 2. 2, negative 2 would mean that I have the x-axis, 2, negative 2. So this is 0, 2. So 2, negative 2 means x is positive and y is negative. So that y must be below the x-axis, right?
Right.
And so this looks like it. This is it now. So now we can label the points. So this point is going to be 2, negative 2, 2, negative 2. And so this is the point 2, of course. This is when x is 2. And this is when y is negative 2. Then right here is when x is 0.
And y
is 2. Very good. And this is how we sketch the curve of y equal to x cubed minus 3x plus 2. And that covers our first class. So what we're going to be doing next week now is we're going to start differentiation for Unit 2. And for differentiation for Unit 2, we're going to be looking at differentiating log functions, exponential functions, and then do implicit differentiation. All right?
Okay.
All right. So will you be joining the Unit 1 class as well?
I was having an issue trying to get onto it because when I created my profile, I specified that I was in grade 13, and so I'm only seeing the grade 13 classes. So
okay, no worries about it. Send me your email, and whenever I'm having the Unit 1 session, I'll send you the link to join the Unit 1. All right?
Okay, thank you.